Welcome to this presentation of the Revit 2014 API. I'll start off with an introduction which covers a few basics of Revit API development very briefly, and then have a quick look at the development themes before we dive into the two main topics, which are the rice and the wine. The rice deals with features affecting existing applications that you need to be aware of to move your previous add-ins from old versions of Revit to Revit 2014. The wine covers all the new functionality that you can use to enhance your add-ins. My name is Jeremy Tammick. I work in the AEC work group in the ADN Autodesk Developer Network. I've been working with Autodesk products for most of my professional life, and now I've been dealing with Revit for the past few years. Revit comes in three different flavors: for architecture, MEP and structure, plus we have a one-box installation which includes all three of those. The product is available to ADN members from the Autodesk Developer Network website. That version is posted once only. Another version is available from the Autodesk public product homepage, and that one is updated with intermediate releases. To run or even to develop a Revit add-in, you actually need nothing whatsoever which is not part of the product, because all of the required .NET assemblies making the API available to external add-ins are present in every Revit installation. The SDK or Software Developers Kit is also included with the product, and it's part of the installation package. It contains documentation and sample code. You can download the latest update of the SDK from the Revit Developer Center, which also has links to a number of other useful tools and documentation. As said, the Software Developer Kit consists mainly of documentation and samples. There's a README first document, a Getting Started with the Revit API document, changes and additions made from previous releases of the API. There's the help file, revitapi.chm, which lists all of the classes with their properties and methods. There's an add-in manager utility, and a huge collection of samples which cover almost every aspect of API development. The Revit Developer Guide is available online from the Autodesk Wiki help. The very first tutorial you should take a look at is My First Plugin. This self-paced tutorial assumes no prior programming knowledge whatsoever and gets you started with Revit add-in programming in 7 easy steps. Other resources available to you are the ADN training material. This is what we use for our hands-on training classes. We have an archive of webcast recordings. That also includes the DevTV tutorial, which is similar to the My First Plugin, possibly a little bit more advanced. Then you can look at the Revit SDK samples. As said, a huge number of sample projects covering most topics. And finally, we have the Building Coder blog, which discusses Revit API issues on a day-to-day basis. 3 items you should be aware of within the SDK are the Visual Studio solution, which enables you to compile all of the samples in one single go, the RVT Samples external application add-in, which enables you to load all of the other samples for testing and debugging, meaning that you just install this one single external add-in, and then all of the other add-ins become accessible immediately. Finally, we have Revit Lookup, maybe the most important tool of all. This enables interactive exploration of the Revit database by displaying the elements in the database with their properties in a dialog. And these properties include links to other elements, so the relationships between the different objects in the database are displayed, and you can navigate through all of this to explore how things are connected with each other. Back to Revit 2014, here is an overview of the main development themes. These are topics that we have been looking at over the past few years and will continue expanding in the future as well. So the platform scalability addresses support for large projects and large teams, dispersed teams. We're looking at design, construction, fabrication to expand the Revit capabilities into new areas. Enhanced support for analysis and simulation. Support for suites and interoperability to connect the different components better with each other. This also includes integrating the add-ins into the Revit user interface ever more seamlessly. And finally, countryfication, which means providing more and more support for enabling standards across the whole world and all of the different regional needs. Here's a slightly more detailed overview of these different areas. I won't go into any further detail at this point since we want to get on with the API issues. We'll quickly scan over the user interface areas without going into any depth. From an API point of view, the most important platform scalability enhancement is improvements to the family load performance. Here are some user interface enhancements that do not affect the API. In Revit 2013, we introduced the possibility to split an element into parts for construction purposes, and that effort has been continued. We now have support to even more accurately represent concrete design, indicate the construction sequencing, and define the primacy of concrete joining. This is also API accessible. In the area of reinforcement, we also have a number of improvements which affect the API, most specifically the new multi-reference annotation possibilities. Steel detailing has been enhanced and enables more precise positioning and geometry definitioning of steel details. A very exciting area is the completely new possibility to display an exploded view of a building assembly. In this view, the elements are displayed in a different location, even though they are effectively, even though the model has not actually been modified. So the elements remain in their original location, but one particular view displays them with a displacement. This displacement can optionally be indicated with dotted lines. Revit 2014 includes a new point cloud engine with support for progressive display of point clouds. In Revit 2014, we can define non-rectangular crop regions, and we have a number of other annotation enhancements. Revit 2014 improves the graphics performance and improves the materials, user interface, and ray tracing. One area of special interest to application developers is Autodesk Exchange. Autodesk Exchange, from the user's point of view, provides access to extended product functionality and expanded content library. And in Revit 2014, we now have the possibility to load an add-in dynamically in mid-session without the need to restart Revit. A new algorithm for determining the analytical spaces, volumes and surfaces from the underlying Revit model elements improves the quality of the GBXML export. In the MEP domain, the calculations now support regional variations by making use of external services. That means that duct and pipe sizing calculations can be moved outside the core product to the API and can be implemented and replaced by external developers. The stairs and railings that were enhanced in Revit 2013 have been further improved based on customer feedback. An important area of countryfication is control over schedules and schedule formatting. That was made accessible to the API in Revit 2013. This access has been significantly extended in 2014 with access to data in individual fields and formatting. Okay, so now we come to the RISE, which are the new features in the Revit API that you need to be aware of to migrate your existing applications. Here's an overview of some of the main RISE topics, which we will be going into in more detail step by step. The various methods to open document files have been modified. Most specifically, they return more detailed information about things that might go wrong. So all of these methods have been re-implemented with specific exceptions. We've also added a new Boolean option to detach a file from Central on opening, and the document save methods also return voids instead of a simple Boolean and signal failures with specific exceptions instead. One important change has been applied to the filtered element collector. It has always been the case that deleting an element while you are iterating over a collection of these elements can cause unexpected behavior. In 2014, such a deletion will actually trigger an exception to be thrown, so applications that are misbehaving in this way will no longer work. In general, it's actually best not to make any changes at all to the document while an iterator is running. That means that if you plan on deleting or even just modifying your elements in any way, the best approach is to first iterate over the document, create a collection of the elements you wish to modify, finish the iteration, and then go over your collection and perform the action that you desire. This action will normally require a transaction, and if you split the whole operation up into these two steps, you can actually perform the iteration first before even opening the transaction. That will clean up your code significantly. A number of methods in the Geometry API have changed. Above all, we are moving away from the creation application and the creation document to static methods on each individual class. On one hand, this makes the methods easier to discover, and secondly, the static create methods on the classes are automatically generated and more aligned with the internal Revit behavior. Another aspect that is cleaned up by these changes is the differing behavior of certain properties, such as endpoint, which is declared to be a property, but it still takes an argument to specify whether it's the start or end point. In Visual Basic, this remains a property, whereas in the generated C# API, a lowercase get underscore was prefixed to the property name. By converting this property to a method in Revit 2014, this kind of ambiguous behavior is removed. Another change affecting existing applications is the loading of family symbols. In previous versions of Revit, whenever a family is loaded, all of its symbols are instantiated and generate geometry. In Revit 2014, for the sake of effectivity, family symbols will not automatically generate any geometry until an instance of the symbol actually is placed in the document. So a symbol geometry will be empty and should not be accessed until it's active. The Revit 2014 API provides a predicate to test whether a symbol is active and a method to actually activate it. Units in Revit have always been a source for confusion. We cleaned up the whole unit handling, implemented a new streamlined units API, and initially planned to retain the old API in parallel to the new one, but finally decided that that would be rather confusing. So the old API has been removed, and that means that applications that make use of some unit methods will need to convert to the new API. One piece of very good news here is that we finally have methods for converting values back and forth into user strings. So format value to string will convert a value to a string respecting the user specified units, and try pass will pass it back from the string into a database unit value. The Materials API has been enhanced, and these are the changes affecting existing applications. We'll look at some further enhancements in the wine section. The IFC export has been converted to an external service. It was already converted to a pure API-based functionality in Revit 2013 and also made open source in Revit 2013. So if you have any requirements for IFC which are not satisfied by the standard Revit exporter, you have the possibility to implement them yourself. The external service is now completely separate from Revit, and that means that multiple external IFC exporters can coexist in the same session. The IFC API classes have now moved out into an own separate assembly. So if you were making use of these IFC classes in 2013, you need to reference the new DLL to work with 2014. The IFC export and import APIs are part of the other DLLs, so they have not moved to the new assembly. And if you are not making use of any custom IFC implementation, you probably do not need to make any modification. So we have a new IFC.NET API DLL, and as you can see from this beta listing here, we also have two new API DLLs for handling macros. Two methods that have been affected by changes are the BeamSystem and Truss creation. Again, movement from the creation document to static create methods on the respective classes. All in all, we've performed a cleanup of deprecated APIs. These are APIs that were causing warnings in Revit 2013. First of all, simply ensure that your Revit 2013 add-in compilation generates absolutely no warnings whatsoever. Then that will considerably simplify your migration after that to Revit 2014 API. So that covers the changes that affect existing applications, and now we'll come to the most exciting part, the wine, to look at new features that were previously not available. One area that we looked at already in 2013 and made significant progress on was the integration of add-ins into the Revit user interface. That has continued, so our support for seamless integration is improving further still. One area that was completely inaccessible to Revit add-ins in previous versions was the project browser. That has now changed. The project browser is supported as an active view. API commands and macros will now be enabled in the project browser, and you can also access the currently selected elements. Previously, the project browser was represented in the API as a view type.internal. That is now replaced by the project browser enumeration value. There's also a system browser enumeration value. The view type internal will continue to exist, but should no longer be used. One of the most exciting enhancements is the completely new copy and paste API. New methods have been added to the element transform utils class to copy groups of elements within documents or between different documents. You can copy view-specific elements. You can obtain the transformation between coordinates of two views. To demonstrate this, we have the following demo. Let's look at one interesting use of the new copy elements method to duplicate views between different drawings. I have Revit open here on a largish model, architectural advanced sample model. And if we look at the drafting views here, you'll see there's a rather messy sample drafting view setup plus a room termination detail. And now we'll run an add-in to copy these two drafting views from this project into another new project. The new project is started up here. I just created that, project 1, and as you can see, it currently has no detailed views at all in it. So I'll switch back to this one, go to the Add-ins tab, and select Duplicate Across Documents. And you can see it's copying and pasting elements, regenerating. It's producing a couple of warnings here, which I can simply accept, and reports as a result that it successfully copied the 3 drafting views that I pointed at, 8 schedules, and 19 new drafting elements. And now if we go to the new drawing here, project 1, you can see these drafting views have successfully been copied across, and we also have a number of schedules added to the project. Another area that developers have been asking for frequently is the possibility to dock their dialogues within the Revit main window. That is now provided by a Dockable Dialog API. So you can register a dockable WPF pane on Revit Startup, and you can implement an iDockable pane provider, which will be called when the user brings that pane into focus. Basically, your dockable dialog will behave like a modeless dialog, but Revit will know about it and automatically switch it in and out of focus as required. The View API was already significantly enhanced in Revit 2013. In 2014, we have added a few more features to complete this. The UI View class, which was introduced in Revit 2013, has new methods for zoom to fit, zoom to sheet, zoom by a specific factor, and to close the associated view. The Preview Control class now has an additional UI View property to access the associated view, and a property to control whether scroll bars should be displayed. I mentioned the non-rectangular crop regions in the user interface overview. This is accessible through the API as well. We can now get and set 3D graphic display options. We can get and set category and element overrides, and we have the possibility to get, set, add, and remove view filters. The boundaries of a crop region are accessible through the View Crop Region Shape Manager, and view and reference callouts are supported. We can also now get and set viewport rotation and center point. In Revit 2013, schedules for the first time became accessible to the API, and we had control over the basics. In 2014, we have additional control over formatting and individual data items. To enable this, the view schedule is now a child of the table view, and the previously existing view schedule APIs are still valid. The white bullets might affect existing add-ins, and the yellow bullets signify new enhancements. So the new table view API controls support access to the header and body table sections and formatting of the table and of individual cell contents. We can also control header grouping and cell formatting through additional APIs. Here is a schedule API demo consisting of 2 steps. First, we'll show how to format individual table cells, and secondly, how to access the data in these cells and export to HTML, including the formatting we set up. So let's look first at schedule formatting. Here we have a simple floor plan, and we've set up a door schedule. And we determined that this schedule is not correctly formatted. So we would like to fix that programmatically, automatically. Let's go to our Add-ins tab and select our schedule formatter. I've set a breakpoint here so that you can see what is going on. We have access to the colors that we need, the highlighting. We would like every second row to be highlighted, and we would like some additional individual cells to be highlighted as well. So if I simply continue debugging here, you'll see the result of that as like this. A second sample application exports this schedule to HTML to show you that I have access to the individual cell data and its formatting. So clicking that invokes my add-in, automatically reads all of the information from the schedule and exports it to a newly created HTML file, which is opened in the browser. Extensible storage was introduced recently and a great success, very useful for applications to save their data within the Revit model. Additions have been made to access GUIDs of all the entities present on an element and to quickly find all elements with data belonging to a specific schema. Previously, the only way to find such elements was to iterate over every single element in the document and check each one individually whether it had schema data attached to it. We've also modified the schema get field and list fields method to respect the access restrictions set up by the permissions. Another very exciting area is the new command API. Previously, there was no way whatsoever for an add-in to launch a built-in Revit command. This has now changed. You have the possibility to post a command. There are obviously a number of restrictions of when this can happen and what kind of commands can be launched. But the good news is it is possible, and there's a list of the postable commands in an enumeration. You can also post external commands created by your own or other add-ins. You can obviously only post one command at a time, and the command will only be executed after the control returns from the add-in which called the post command method. There is also a command event which notifies you before an add-in command is executed. Another new API is the add-in API, which enables for the first time the loading of an add-in into Revit in mid-session. So you can load a new add-in manifest file without restarting Revit. Obviously, in this case, the onStartup method of an external application will not be called. So an application that is willing to participate in this process needs to deal with that situation. There's a load add-in method to programmatically load an add-in. An add-in can decline to load into the active session. That is done by setting a specific tag in the add-in manifest. And obviously some operations cannot be completed in this situation. So, as said, an add-in that participates in this needs to deal with it. The reason why this is important, obviously, is to enable add-ins to be downloaded by users from the Autodesk Exchange store and tested immediately without the need to restart Revit first. The annotation and visualization topics enable enhanced model documentation. The Materials API has been extended. We can now assign an appearance asset to a material, create an asset element for rendering, retrieve assets, and set rendering assets to a Revit element. As I mentioned in the short user interface overview, we have a new multi-reference annotation API. We have new tag types which can reference multiple identical elements, and full support and access for this through the API. I mentioned the new dimension and units API in the RICE section. From the wine point of view, we now have support for alternate units, so you can make use of two different unit systems in the model for display to the user simultaneously. I mentioned the displaced views. This is also completely accessible programmatically. The programmatic access to the displaced elements makes use of a displacement element, which is attached to an existing element and causes it to appear to be displaced from its actual location. There is also a displacement path object, which enables you to create an annotation line connecting the displaced element to its original location. Here is a demonstration showing how the Displaced Elements API can be used to animate an exploded view of a complex model. So we have this model loaded and the animation add-in installed. So if I go to the add-ins tab and click on displacement animation, the elements are first displaced away from their original location and then moved back again in an animated sequence, step by step, level by level, and category by category. While that is still going on, we can switch over to the source code and have a look at some of how that is implemented. So if we go to the animator, you'll see during the start animation sequence all of the different levels, and then go through each level and collect the different kinds of elements of interest, such as foundations, structural framing, floors, walls, structural columns. Then we start the animation and iterate through each of these groups, displacing them back again step by step. Let's go back to Revit and see the final result here. And there we are back again to the beginning. The area of modeling is important for representation and interoperability. Sketchplanes are used in numerous situations. Now, the sketchplane can be created by providing it with an element ID from a grid, reference plane, or level. There is access to the geometric plane from a sketchplane and the plane reference. Sketchplane creation has also moved away from the creation document and the item factory base object to static create methods on the sketchplane class. A new intersection method enables the calculation of an intersection of a curve with a solid. Obviously, in this case, the results of the intersection may be multiple curve segments, so these are all accessible, plus information on whether they lie inside or outside the solid. I mentioned the new concrete modeling functionality in the user interface. From the API point of view, we have control over joining of elements through the join geometry utils class. We have a join geometry method to create a Boolean union of two elements. They can be unjoined again, and we can switch the joining order. There are also test methods to check whether an element cuts its target, has been joined, or to access joined elements. Very important in Revit 2014 is much more intelligence in imported forms. So, for instance, an ASYS solid coming in from a DWG file will be interpreted and analyzed by Revit, and planar surfaces will be identified. These can then be offset to modify the resulting solid. That means that you can now in Revit 2014 use one single solid to define a whole parametric family of parts by importing the shape that you require and then modifying the offset of various planar surfaces on that shape to generate numerous different similar types. We have a new FreeForm Element API, which defines a form subtype containing non-parametric geometry. It's created from an input solid outline, can be added to families, participates in joins and void cuts with other elements, and as mentioned, its planar faces can be offset along the normal vector of the face. So there's a static create method to create a new instance of a freeform element, and there's the set face offset method which offsets planar faces by a specified distance. Here's a demonstration of making use of these freeform elements. This demo shows how geometry can be created, solid geometry, from a set of input boundary curves, and also how the Boolean operations can be used in the project environment. I have a wall here, which is irregularly shaped, as you can see, and a set of boundary curves defined by model lines. I'll go to my Add-ins tab and launch my FreeForm Create Negative Block add-in. It is prompting me to select the target element, so I'll pick this wall, and then select the boundary. So I'll go and pick these lines one by one and say finish. I've set a breakpoint in the helper method create negative block so you can see what is going on. The first method that we go to is the get contiguous curves from selected curve elements, which picks the boundaries and puts them together in the appropriate order to define a curve loop from them. I'll step over that. In order to create the new element, we need to open a family document. We'll use a generic model template, then create the extrusion geometry from our closed loop, get the target solids, make sure that we have one single target solid to start out from. We want to create a new freeform element in the family document that we just set up. So we need a transaction for that, and that succeeded and committed. Now we can load the newly generated family document into our project and close it. We'll pick the symbol and place an instance of that, and there you can see the result. If I hide the wall, you can see the resulting block. I'll display that shaded to give you a better idea of the result. One area where you can see practical use of that kind of functionality is the new Site API. It includes a Site subregion class. That's a special class obtained from the topography surface. You can create, read and write its boundaries. Additionally, there's a new building pad element. The new building pad element makes use of the Site subregion. The Site API enables us to edit a topography surface. To do so, we require an edit scope, the topography edit scope. It's sort of similar to a transaction, so you instantiate this scope, make changes to your model, and commit these changes at the end. And within such an editing scope, you can add points to the topography surface. One effect of this is that the document is no longer regenerated. You can read existing points from a topography surface and identify whether a point is contained or whether a specific point is an interior or a boundary point. Here's a demonstration of making use of the Site API. So let's take a look at the Site API demo. We have implemented an add-in which enables us to manage ponds. We can add a pond, raise the terrain, lower the terrain, normalize it again, move the pond, which is implemented as a region, and delete it again. So let's add a pond. I've set a breakpoint here in the add new retaining pond method, which shows you the steps that we go through. We either pick a topography surface or we select the first one found in the document. We pick a point on the surface to define the location of the pond. We create the curves, in this case 2 arcs to define a circle. And then we encapsulate the whole database modification in a transaction group. And the first transaction is implemented to add a subregion. The second one is editing this region, which requires a topography edit scope and a new transaction to add the points. And here you can see how the edit scope is committed and started just like a transaction. I clicked add pond and it's prompting me to select a point. So I'll place the pond right here. You can see in the status bar the progress being made. I have a new subregion on my topography surface. If I ask the terrain to be lowered, it asks me to select the appropriate subregion and lowers that for me. Or if I want to move the region again, I can pick this element and pick a new location. And each time you can see how the original surface is restored again afterwards, or finally to delete it, I pick it and everything is restored back to its original state. Beam and brace ends are still accessible through the parameter API, but we also have new built-in parameters to replace the start and end extension ones. We have justification parameters valid on the beam. I mentioned the new reinforcement functionality. From the API point of view, we have new reinforcement classes for area reinforcement, path reinforcement, fabric area, fabric sheet. On the rebars, we can set the hook orientation, compute the driving curves, obtain the constraints manager, and access the rounding overrides of reinforcement elements. In the MEP API, the electrical load classification data class has been modified and extended. It now provides several new string properties corresponding to the electrical panel schedule load classification data. The fitting parameters that were previously defined in separate CSV files are no longer used. Instead, the fitting parameters are now managed through new APIs. There's a fitting angle usage settings API applying to ducts, piping, and electrical systems. The duct settings provide access to size prefixes, suffixes, and annotations, and we have added air density and viscosity as a new analytical property. Also in the MEP API, the element creation is now provided as static methods on the respective classes. The connector elements can now be created in families centered on faces. We can access the connector system type and we can flip the connector direction. I mentioned previously that several MEP calculations have now been moved out to external services, which enables them to be replaced by external application developers and adapted for local requirements. A number of enhancements apply to model management, obviously to ensure coherent data interaction. The Document Open API provides new functionality through the Open Options class, so you can specify auditing behavior, whether to expand all elements and check for corruption. You can specify whether the local file can be opened by the wrong user, and you can read and set the open work sets. When saving a document, a new option allows you to compact the document to remove redundant data from the file. You can specify the maximum number of backups and set work sharing options for saving as central, opening default work sets, clearing the transmission data. The Worksharing API introduced in the previous version was read-only. It is still mostly read-only. There are some enhancements which allow some control to be taken. So you can reload the latest, check whether changes from central have all been applied, specify that synchronize with central should be executed, and there's some access to element ownership, so you can check out elements, check out work sets, and relinquish ownership again. You can also create a new local file and enable work sharing on a document. Linked files were previously not very accessible from the Revit API. We are starting to make them more accessible, and a number of enhancements have been made to control links. One area is loading from and unloading a link, or getting and setting the paths, so you can use relative, absolute, or server paths. You can also specify which worksets to open when creating a new link. Continuing with the linked model access, we can identify whether a document is linked, or unload a specific link, access the linked document, and interact in some extent with linked models. So it is now possible to create room tags for linked rooms, prompt for selection of elements in a linked file, convert geometric references between the link and the host, execute some room boundary analysis, and place family instances on faces defined in the linked file. Related to the Link API, we have some enhancements for interoperability. We can import and link SAT files and SketchUp files and import with markup. More interoperability functionality concerns the export. There's a Navisworks exporter through an external add-in, and there's access to the export data in DWG, IFC, and DGN files through table mappings for layers, line types, fonts, patterns, and line weights. A very exciting new enhancement is the custom exporter, which can be defined to access the internal Revit rendering pipeline. That means that if you have an add-in which is interested in the graphical representation of the model, such as surfaces with their associated colors and materials and textures, you can subscribe to this rendering pipeline and access that data directly without having to iterate over the entire database, access each individual element, query it for its geometry, find out whether the geometry is in the correct location and what materials should be applied to it, and so on and so forth. So this can be a huge simplification for all rendering requirements. In the iExport context interface, you receive the output describing the model just as it appears in Revit, including all of the geometrical and material properties. We have a number of enhancements for macro development, enabling rapid prototyping. One enhancement is that the Sharp Develop environment now also supports development of macros in Ruby and Python, as well as C# and VB.NET. We have also implemented a new macro API located in new API assemblies, Revit API macros DLL and Revit API UI macros.dll. This functionality enables us to list, add, and delete macro modules, list, add, delete, create, and execute macros, and access the macro security settings. So now macros can be generated programmatically and launched programmatically. Here is a list of resources for further learning. The first place to start is always the Revit Developer Center, where you can access the Revit Software Developer Kit, including all the samples and the API help file. There's also a link to the DevTV, Introduction to Revit Programming, and the My First Revit plugin tutorial. The Revit API Developers Guide is accessible online through the Autodesk Wiki Help. We have an archive of webcasts and trainings. There's a discussion group at discussion.autodesk.com dedicated to the Revit API. The Autodesk Developer Network provides API training classes. There's the Building Coder blog dedicated to the Revit API and updated several times a week. You can become a member of the Autodesk Developer Network if you wish to interact more closely with Autodesk and be notified of confidential information, have access to pre-release versions and versions of all the released software. There is a DevHelp online service for ADN members in which we provide guaranteed answers to your queries. Thank you very much for your attention, and I wish you much success working with the Revit 2014 API.